Welcome to the discussions of the past year questions. This video, we shall take a look at further mathematics, further pure mathematics 2, paper 2, October-November 2023, paper 22. Let's take a look at the first questions. Find the Maclaurin series of ln x plus 2 plus ln x squared plus 5 up to and including the terms in x squared. So what you need to do is we need to use the formulas. Just refer to the formula booklet FF19. Ln 1 plus x is x minus the x squared over 2 plus the x cubed over 3 and so on. Okay, well, we just refer to the formula booklet FF19 will do. Then now for the ln of x plus 2, you need to factorize the 2 out. Factorize the 2 out, you make it become 2 here. Then this is a 1 plus x over 2. So that this you can split them to become ln 2 plus the ln of 1 plus x over 2. Then you just use this result that you have stated earlier. Then just change all your x become x over 2. So just list it out like this. But the question only want until x squared. So when you see until x squared, then you can stop over here. So this one, it will be equals to ln 2 plus the x over 2 minus the x squared over the 8. I call this one first equations. Then ln of x squared plus 5, I will factorize the 5 out. Make it become 1 plus the x squared over 5. Applying the law of logarithm. Same thing like just now. We get this. Then this will be a ln 5 plus the x squared over 5 minus a dot. I call this on second equations. So what I need to do now is to join the first equations and the second equation together. So you get ln x plus 2 plus the ln x squared plus 5. It will be approximately equals to ln 2 plus the x over 2 minus the x squared over 8 plus with the ln 5 plus the x squared for 5. Expand and simplify it, you get ln 2 plus ln 5 plus the x over 2 minus, this one just use your calculator, these two join together, negative 1 over 8 plus 1 over 5. So you get 3, positive 3 over 40 x squared. Of course, these two can combine together. Ln 2 plus ln 5, you can multiply 2 times 5, then you can get ln 10 plus the half x plus the 3 over 40 x squared. That would be better. Okay, just like that, done. So this will be the answer for the question number 1. Move on. Question number 2. So look at question number 2. It is given that x equals to the 1 plus 1 over t and y is equal to t multiplied by e power t. So this one is a parametric equation. Show that dy dx equal to this. So what you need to do is to differentiate the parametric equations separately. dx dt, you get this. dy dt, keep the left, differentiate the right, plus keep the right, differentiate the left. And you will get e power t, e plus 1. Okay, then the dy dx is actually dy dt divided by the dx dt. So you are getting this e power t, t plus 1 divided by negative 1 over t squared. Simplify it, you will get negative e t multiply everyone by t squared here, you will get t cubed plus t squared shown. That will be the answer for the part A. Move on. Part B. Find d square y dx square in terms of t. So to find the d square y dx square in terms of t, just need to differentiate like this. Then this one is d dx of the negative e power t cubed plus t squared. So over here, we will use the chain rule to split them to become a dt here. And this one is a dt dx. So this one is keep the left, differentiate the right, plus keep the right, differentiate the left. Multiply by dt dx. dt dx is a negative t squared. Expand. You can see that the negative, and the negative, you can factorize it out. The e power t and the e power t also can be factorized out. So you will get et t squared. Inside one over here, just join together. You will get t cubed. Then plus the 4t squared plus the 2t. Okay. Over here, if you want to get a better form, you can actually factorize another t out, make it become t cubed here. This one t squared plus 4t plus 2. That will be your second derivative, t squared y dx squared for the part B. Move on. Will be question number 3. Okay, now we take a look at question number 3A. Use the Moivre theorem to show that the cos 5 theta equal to the 16 cos power 5 theta minus 20 cos cube theta plus 5 cos theta. So for these questions, we just need to let the cos theta plus the I sine theta make it become the initial C plus IS. Then power the 5 for both sides. The reason we power 5 because there's a power 5 here. So we just put power 5. Your left-hand side, we use the Moivre theorem. So the Moivre theorem says that the power can bring into the data become the multiple. So you have 5 data. That is your de Moivre theorem. Your right-hand side will be binomial expansion. So binomial expansion, this one just expand. So if you can memorize the Pascal triangle, so this will be the expansion, 5c cubed, 5c power 4, is plus the 10c cubed, is square plus the 10c square, is cubed plus the 5c, is power 4 plus the is power 5. So if you rearrange and group the real parts together, all the real parts together, you have c power 5 minus the 10c cubed s square plus the 5c s power 4 plus the I of the 5c power 4s minus the 10c square s cubed plus the s power 5. If you group them together according to the real part and the imaginary part. So since we only want cos 5 theta, we only want the real part. By considering the real part, you have a cos 5 theta equals to the c to the power 5 minus the 10c cubed s squared plus the 5c s to the power of 4. And we do have the formula of cos square theta plus the sine square theta equal to 1. However, over here, we will write it as a c squared plus s squared equal to 1. Okay, we have c squared plus s squared equals to 1. That means the s squared can be written as 1 minus c squared. Okay, so because of this trigonometric identity, cos squared plus sin squared equal to 1, then we have s squared equal to 1 minus c squared. So over here, we will change the s squared to become 1 minus c squared. Okay, because the result that we have only have cos, do not have sine. So we just need to change accordingly. Expand c power 5 minus the 10 cube plus the 10c power 5. Then this one is a plus the 5c power 5 minus the 10c power 3 plus the 5c. Then you get 16c power 5 minus the 20c power 3 plus the 5c. So therefore, cos 5 theta equal to the 16 cos power 5 theta minus the 20 cos cube theta plus the 5 cos theta shown. Okay, so this is how we show the answer for the part A. Now we move to the part B. Hence, obtain the roots of the equations for these polynomial equations. So what you can do here is that we need to know how to link them to the part A. Okay, so obviously it's related to the part A. We need to know how to link them to the part A. So from what we have here, 32 s power 5 minus the 40 s cube x cube plus 10x minus the 2 equal to 0. We let our x equal to the cos theta. Then you have a 32 cos power 5 theta minus a 40 cos cube theta. In order to link with the part A, you need to let the x equal to the cos theta equal to 2. Then over here, you can see that this one is 16, 20, and 5, but this one is 32, 40, and 10. So it's actually the 2 times of it, 2 times of the original equations. So we can just make it become 16 cos power 5 theta minus the 20 cos cube theta plus the 5 cos theta equal to the 2 over 2. Divide everyone by 2. So this one you can simplify, become cos 5 theta equal to the 2 over 2. Okay, so this is what you are having. So our job here is to find x. Okay, so in order to find x, we need to find the theta. So to find the theta over here, we need to go for the general solution of the theta. So the general solution for the 5 theta, cos 5 theta equal to just 2 over 2. So the 5 theta general solutions, it will be 2n pi plus minus the pi over 4. Okay, because cos pi over 4 is equal to 2 over 2. And cos negative pi over 4 also will give you 2 over 2. Okay, and then we just put the plus 2n pi in front. Okay, so over here you're supposed to have this and your n starting from 0, 1, 2. Okay, and so on. But however, we know that we're looking for 5 result, 5 answer only, because it's 5 theta power 5. We're supposed to have 5 values only, 5 roots. So over here, your answer is going to be, when n is 0, you are having pi over 4. Negative pi over 4, we can ignore it, because cos pi over 4 and cos negative pi over 4 are the same. Okay, so we just put, this is for the case n equal to 0. Okay, then after that, we are having the n equal to 1. Okay, so we are having n equal to 1. When n equal to 1, you have 2n pi. N equal to 1, you have a 2 pi plus minus pi over 4. So 2 pi plus minus pi over 4, you're supposed to get 7 pi over 4. and 9 pi over 4. Okay. Then when the n equals to, when the n is equals to 2, when the n is equal to 2, you have a 4 pi plus minus pi over 4. 4 pi plus minus pi over 4, you will have 15 pi over 4 and 17 pi over 4. Okay, so you have 5 results already. So your data will be cos, your data will be pi over 20, 7 pi over 20, 9 pi over 20, 15 pi over 20, and 17 pi over 20. So therefore, your solution, x is equal to the cos pi over 20, cos 7 pi over 20, cos 9 pi over 20, cos 15 pi over 20, and the last one, it will be cos 17 pi over 20. Okay, let me write properly. So this is the 5 results, okay, because you are looking for the power of 5, you're supposed to have 5 roots. But however, if you refer to the mark scheme, the mark scheme give you another one is 33 pi. Mark scheme giving you cos 33 pi over 20, and the mark scheme giving you cos 25 pi over 20. Okay, but you can see that these two answers are the same. These two answers are the same. So that means my answer over here, cos 7 pi over 20 can be accepted. Cos 15 pi over 20 also can be accepted, because at the end, the answer is the same. If you change it to become cos 7 pi over 20 and cos 15 pi over 20. So the answer is the same, no worry. Not really have to be the same answer as in the mark scheme. So this answer is correct. Okay, so then this will be the answer for the question number 3B. And moving on, question number 4. Now we take a look at question number 4. Find the solutions of the differential equations dy dx plus 3y equal to the sine x, which y equal to 1 when x equal to 0. Give your answer in the form of y equal to fx. So what we need to do is that over here, we know that this is a linear equations. We can solve this equation by finding the integrating factor. So we need to know how to find the integrating factor. Integrating factor consider as we call it IF. It will be e to the power of 3 dx. Taking this value 3, not 3y, it's 3 only. Just taking the value 3 and then you integrate it. So it will be e power 3x. Multiply everyone by the IF from the equations. You get e power 3x dy dx plus the 3 e power 3x y equals to e power x, e power 3x sine x. So what you need to do is to take the IF, multiply by the y. It will be equal to the integrate this. Okay. So now we have a problem because to integrate this is not that straightforward. So over here, we will stop our solution over here for a while. Okay, just stop here for a while. We just need to let this integration call I. Using integration by MAT, L-I-A-T-E, T first and E later. Okay, so actually you can, over here, either one is fine. Over here, 3 go, move out. Then integrate e power 3x, you get 1 over 3 e power 3x minus cos multiply 1 over 3 e power 3x dx. So you get 1 over 3 e power 3x sine x minus a 1 over 3 e power 3x cos x. We need to do the integration by part one more time. So this one, the front one, just copy down. Okay. So over here, you have a cos x 1 over 3 e power 3x minus the negative sin x 1 over 3 e power 3x dx. Expand, simplify. Minus a 1 over 9 e power 3x cos x plus the 1 over 9 I minus, not plus. This is a minus. There's I here as well. So you just join together. You get 10 over 9i equals to 1 over 3 e power 3x sin x minus a 1 over 9 e power 3x cos x. Now we put a plus c. Therefore, your I will be the 3 over 10 e power 3x sin x minus the 1 over 10 e power 3x cos x plus c. Then we need to find the c. Given when x equal to 0, I haven't finished yet because what I found is only I. I need to substitute the I inside here. Okay, sorry for that. Okay, so now this one I erase. So from here, therefore, e power 3x y is equal to the 3 over 10 e power 3x sin x minus a 1 over 10 e power 3x cos x plus c. Then given x equal to 0, y is equal to 1. So you have a 1, 0, c is 11 over 10. So therefore, your y will be equal to the 3 over 10 sin x minus a 1 over 10 cos x plus the 11 over 10 e power negative 3x. Okay, so this will be the answer for the question number 4. Move on, we have question number 5. Okay, now we take a look at question number 5. You have a diagram here, you have a graph here. The diagram shows a part of the curve for the y equals to the x secant sec square x, and its maximum point is m. Show that at m, 2x tangent x minus 1 equal to 0, and verify that this equation has a root between 0.7 and 0.8. Okay, so for this question, to find maximum, we need to do the differentiations, dy dx. So for this case, just direct differentiate dy dx, keep the left, differentiate the right. Then this one is the negative sec x tangent x plus the keep the right, differentiate the left. So if you expand and simplify it, you will get negative 2x sec square x tangent x plus sec square x. Okay, so this is your dy dx. Then for the maximum, you need to let your dy dx equal to 0. You factorize the sec square x out, then you will get negative 2x tan x plus 1 equal to 0. So in order to get in order to get dy dx equal to 0, either the sec square x equal to 0 or the negative 2x tan x plus 1 equal to 0. For this case, sec square cannot be 0. Okay, so you need to understand that sec square is actually 2 over the e power x plus e power negative x square. Okay, so this one cannot be 0, because if it's 0, that means your e power x need to go to the infinity. Okay, so this is not what we want. Okay, so this one we just say that it cannot be 0, so we ignore it. Okay, so you ignore, which means that the 2x tan x minus 1 must equal to 0, shown. Then the question wanted to verify that there is a root between 0.7 and 0.8. That means you can see that you have only one maximum. Okay, so that means you have one value that will fulfill this condition equal to 0. How do you verify that? What you need to do is just to let the fx equals to the 2x tan x minus 1, and you put 0.7 inside and 0.8 inside. Using the calculator, you can get 0.7 is negative 0.154, and you can get this f0.8 will be 0.0625. This is a negative value, this is a positive value. Okay, so just say that because of there is changes of sign between 0.7 and 0.8. Therefore, this equation has a root between 0.7 and 0.8. Just like that. So this will be the answer for your question part A, question number 5 part A. Now we move on to the question number 5B. By considering a suitable set of rectangles, use the diagram to show that the series here less than this relationship. Okay. So what you need to do here is that you need to understand that when you have series over here, that means this one must be area of rectangle. And this one must be the integrations. So when we talk about integrations, we're talking about the area under the graph. So we need to use a diagram to confirm where we should use the where we should start from, the area of rectangle. But first, we let this call the function fx equals to the x sec square x. Okay, so you can see that this one is actually a 2. That means we're supposed to start from 2. Then after that, we put f1, f3, and then until the fn. Okay, the meaning for this one is actually quite clear already. Okay, but what is it got to do with the area of rectangle? So if you look at the diagram, this is actually the diagram. Then you can see that this, maybe you just write it 1, 2, 3, 4, and so on and so on and so on until you reach the value n minus 1, and then you reach the value n. So you can see that if you try to, okay, maybe I try to draw 2 here, 3 here, 4 here, and so on and so on. Okay, then this, if you want the area to be less than, area of rectangle to be less than the integrations, that means the rectangle that you choose must be shorter. Okay, must be shorter. The rectangle that you choose must be shorter. Okay, so this one just a sketch only, just for you to get the idea how it works. Okay, so you can see that this one, it will be called F1. This one will be called F2, and this will be called F3. And you reach until here, this one, it will be Fn. Okay, so all the the height that I choose over here, actually all the height will be less than the area, less than height of the graph. Okay, but however, you can see that the questions start from F2. The question start from F2 and ends at Fn. So that means F1 they don't want. F1 they don't want. So what you need to do is just need to write the area start from here. This area start from here. And you can see that the width over here is all 1 unit. The width over here is 1 unit. So you can just start from the area of rectangle, which is F2 times 1, plus the F3 times 1, plus until Fn times 1. So F2 times 1, plus the F3 times 1, plus until you have Fn times 1. This will be less than the integrations of the function x sec square x. But what is the integrating limit over here? From where to where? So from the diagram, we can write, if you write 0 to n, if you look at the whole area, supposed to be integrated from 0 to n. But 0, if you put in here, sec square, if you put 0 inside, sec square, if you put 0 inside, okay, I can, no problem. But the question, over here, we actually want it to be, you can see that from the result over here, they want this value to be a 1. And then they want this value to be an n. So from here, it's actually telling us that we want the integrations from 1 until n, from 1 until n. Okay, so we are actually looking for the area here. The area that we're looking for is actually from 1 until n. So we're looking for this whole area from 1 until n. But when we talk about the area of rectangle, we only consider the height that start from 2. Okay, so if you consider the integrations, we will consider it from 1 until n. Okay, so this is based on the information given. This is what we can decide. Okay, so we are doing it from here. Then you can write this one as the sum of the r equals to 2 of fr less than. Now you can start to do the integrations by part for the right hand side. Integration by part over here, you can just integrate sec square. You get tan x minus this one differentiate x, you get a 1. Then this one integrate, you get tan x. The integration value is from 1 until n. Then this one, now you can write it as a r sec square r less than x tan x minus integrate tan x. Integrate tan x, you will get ln cos x. Ln cos x. Okay, ln cos x. Okay, but you can see that the result given, the expression given over here is they want sec, ln sec, not ln cos. So how do you make ln cos to become ln sec? So what you can do over here is just to bring the negative here, goes up, make it become positive, then you will get ln sec x. So this one now it will become x tanh x plus the ln sec x 1 until n. So now you just put in the n, you get n tanh n plus the ln sec n minus the tanh 1 minus the ln sec 1. Okay, so this will be the result and shown. Done for this number part B, number 5 part B. Okay, so now we move on, go for the question number 6. We go for question number 6, state the eigenvalue. So for this eigenvalue, you can see that the lower triangle all 0 over here. That means the diagonal here, the whole diagonal here, that will be your eigenvalue. So you can see this question only 1 mark. So no need to do any, no need to show any steps. Just direct write down the eigenvalue. So eigenvalue, I will use lambda to represent it. Is equals to the 1, 2, and -1. Okay. Now we want to use the characteristic equations of P to find the P inverse. So the characteristic equations of P is actually coming from the determinant of the P minus a lambda I equal to 0. So, but it's actually just coming from the root over here. Lambda minus 1, lambda minus 2, and lambda plus 1 equal to 0. So what you need to do over here is just to expand them. So just expand them one by one. I will take these two multiply first because this one, it will give me lambda square minus 1. Then after that, I have lambda cube minus the 2 lambda square minus a lambda plus 2 equal to 0. Okay. So from Cayley-Hamilton theorem, say that P cube, change your lambda, become the matrix P. So you get P cube minus the 2P square minus the P plus the 2I is equal to 0. So you can have the 2I is equal to the P cube. Oops, sorry. 2I is equal to the 2P square plus P minus the P cube. Then you multiply by P inverse. Then you get 2P inverse equal to the 2P plus I minus a P square. Then your P inverse is actually half of 2P plus I minus a P square. I have P, I have I already, but I need to have a P square. So before I continue with the steps, I need to show the value of the P square first. So P square is this matrix 1, 0, 0, -1, 2, 0, 1, 1, -1, multiplied by 1, 0, 0, -1, 2, 0, and 1, 1, -1. So just expand them accordingly. You will get 1, 0, 0, -3, 4, 0, and -1, 1. -1, 1, 1. Okay. So that is the P square. Then, therefore, my P inverse is actually half of the 2P, or the P times 2 plus the I minus the P square. Simplify it. So just add together. So you get this will be 1 half 3 over 2, 0, 0, 0 over here. Then this one, it will be a half. This one will be a half as well. This one will be, the last one will be a -1. So this will be the B inverse. This will be the B inverse. This is how you use the characteristic equations to find the P inverse. That will be the answer for the part B. So now move on. We are having a matrix A. Then they say that this matrix A has a distinct non-zero eigenvalue. So all the eigenvalue here are non-zero. That means obviously they're telling you that the A is non-zero. Okay. Then with corresponding eigenvector, that means this eigenvalue will correspond to this eigenvector. This eigenvalue will correspond to this eigenvector. This eigenvalue will correspond to this eigenvector. Then they want you to find the A inverse in terms of A. So you can see that actually if you combine them together as a one matrix, you can see that this one is actually same as the matrix B, right? It's the same as the matrix B. Okay, so this is actually a B. Okay, so this is something you need to know how to link them together. Okay, so that means the matrix B, the matrix B, the matrix A, the matrix A with the eigenvalue like this will link you to the eigenvector. Then this matrix A will give you the B. This eigenvector will give you to the matrix B. Okay, so from here you should be able to get the relationship that the A inverse is equals to the B inverse. Okay, you can start from here. But I think before that we need to find the diagonal value. Okay, so maybe we call this a B. Okay, I call this a B. B is the diagonal value, diagonal vector. A half 2, 0, 0, 0, 0, 0, 0. Okay, and the A inverse equals to the P inverse is actually equals to the B inverse. Okay, so the D is actually B inverse, so it will be A 0, 0, 0, half 0 and 0, 0, 2 inverse. Then it will give you 1 over A 0, 0, 0, 2, 0, and then 0, 0, half. That will be the matrix D. This will be the matrix D. Okay. Then after that, from this result, A inverse is equal to the B inverse. Then you can see that just write down the matrix for all of them. Your B is 1, 0, 0, -1, 2, 0, 1, 1, -1. Your B inverse is 1, 0, 0, half 0, 3 over 2, half, and then -1. And then this one is the diagonal matrix. Okay, so what I need to do, I will take these first two multiply together first. Then the last one I just copy down. So the first two I multiply, I get 1 over A, 0, 0, -2, 4, 0, and half, -half. Okay, now I multiply the remaining two. Then I get this answer as a 1 over A, 0, 0, 1 over 2A minus 1, 2, 0, 3 over 2A minus the 3 over 2, 3 over 2, and then a half. So this will be the answer for the A inverse. Just like that. That will be the answer for the question number 6C. And moving on, we have question number 7. Okay, now we take a look at question number 7A, starting from the definitions of cosh and sine in terms of exponential, prove this relationship. So for this situation, you just need to, you can either start from left or you can start from right. So over here, I start from left. Okay, so I have 2 sine square. So according to the definitions, sine is actually e power a minus a e power negative a over 2 and square it. So if I square, I have to expand it. I get e power 2a minus 2 plus the e power negative 2a over 4. Then I expand them again. I get e power 2a plus the e power negative 2a over 2 minus a 1. If I expand them accordingly, then you can get this as the cos 2a minus 1. That will be equal to your right-hand side. Then your identity has proven. A, done. Now we move on to the part B. The curve has the equations y equal to x squared for x from 0 to 2 over 3. The area of the surface area generated when the curve is rotated 2 pi radians about the x-axis. So you need to know that if it is a surface area generated 2 pi radian about the x-axis, okay, so we know that the formula is going to be a 2 pi y dx. Sorry, the formula is supposed to be 2 pi y square root of 1 plus dy dx square dx. Okay, so this is the formula. But however, I cannot start from here yet. I need to find this part first. Okay, I need to find the dy dx first. So let us find the dy dx first. The dy dx is actually quite simple. Dy dx is 2x. So your square root of 1 plus the dy dx. Okay, no need to simplify. No need to simplify it. So we can just start from the surface. It's a 2 pi. Integrate from 0 to 2 over 3. And then square root of 1. I forgot to write down the y. So maybe I write down the formula first. Then I will get 2 pi, 0, 2 over 3. The y is a x squared. 1 plus the 4x squared dx. Okay, so this is what I supposed to start from. Then the questions want you to use this as a substitution to show that s will going to be equal to this value. So now we let x equals to the half sine u. Okay, then your dx du will be the half cos u. Okay, so your dx is going to be half cos u du. And when x equal to 0, you are having 0 equal to the half sine u. That means your u is the half sine of 0. You get a 0. Then when the x is equals to 2 over 3, so you get 2 over 3 equals to the half sine u, and your u will be the upside of 4 over 3. So upside of 4 over 3, because the answer, they only one answer in terms of ln, we need to use the inverse hyperbolic functions in terms of ln. Then you can just use the formula. Just refer to the formula booklet MF19. You can get upside of 4 over 3 is actually ln 4 over 3 plus square root of 4 over 3 square plus 1. Use your calculator, simplify it, then you get the ln 3. Okay, So these are the things I need to get ready for my integrations. Okay, so now everything ready, we can continue with the surface area. So now I need more space. I write this one down. So S is equal to the 2 pi. I change the 0. When the x is a 0, you will get 0. X is a 0, you'll get 0. But when the x is equal to the 2 over 3, this one will become ln 3. So x squared, your x is a half sine u, square root of 1 plus the 4x squared. Then this one is the half cos u du. Okay, so this is what I have. Expand simplify. So we will have a lot of things to do over here. You get a 1 over 4 sine square u, square root of 1 plus the sine square u, half cos u du. So you need to understand that this is same as a cos u, cos square u. Cos square u, if you square root it, you will get cos u. So cos u multiplied by cos u, again, you will get cos square. Okay, so over here, you can do step by step, right? Okay. Then the 1 over 4 and the half here, I will bring them out. Constant, I will bring them out. Then after that, I will multiply by 2 pi. Okay, so it will be 2 pi divided by 8 from 0 to ln 3 sine square u, and then cos square u du. Okay, so you need to understand that we are having a formula. Sine 2u is equal to the 2 sine u cos u. So, but this one is a square, but this one need to go over here as a half. Is equal to the sine u cos u. Okay, so and then after you square it, after that you square it. So this is something you need to know. And I will erase this. I will straight away write this one out. Pi over 4 from 0 to ln 3. This is a 1 over half sine 2u square du. So if you take the constant out, you get pi over 60. You will get sine square 2u. So now we reduce our problems over here to become integrate sine square 2u. How do we integrate sine square 2u? Same thing like the trigonometry problem. We still need to use the trigonometry hyperbolic identity. The integrate sine square 2u, we have a formula saying that the cos for u is actually 1 plus the 2 sine square 2u. Okay, we have a formula like that. So that means that sine square 2u, it will be cos 4u minus 1 over 2. So this one, it will become cos 4u minus 1 over 2 du. So just direct use of formula will do. Then again, I will take the 2 out, make it become pi over 32. Now inside here, I just integrate directly. I get 1 over 4 sine 4u minus the u. And now I'm ready to substitute the u from 0 to ln 3 inside. I get pi over 32, 1 over 4 sine 4 ln 3 minus the ln 3 minus a 0, or the whole thing 0 here. Okay. So just you can use your calculator. Sine 4 ln u. Actually, because sine Sine 4 ln 3. Sine 4 ln 3, yeah, is actually e power 4 ln 3. Actually, just use calculator. Let me check with the calculator first. Is calculator able to produce to you the result directly with a nice value? So okay lah, can. Our calculator can provide to you the result directly. So we will just apply it. No need to show anything anymore. Just direct use calculator. This will be 1/4, giving you this one as a 3280 divided by 81 minus a ln 3. Okay. Okay, but 3280 can divide by 4, right? 3280 divide 4, 820. So at the end, you get pi over 32. 820 divided by 81 minus a ln 3. Shown. That is the answer. You can see the answer is correct. Okay, so shown. So that's it. That will be the answer for this question number 7B. And okay, move on. We will have one more question, question number 8. So now we go into the question number 8. This one is a second order differential equation. Given that the v equal to y power 4 and the second order differential equation look like this, show that this can become this. Okay, so how are we going to show it? This is the substitution. So what you need to do is just do the implicit differentiations. dv dx, we're going to give you 4y cubed dy dx. Okay, just like that. Then you can see that the d square v ds square, we differentiate it for one more time. Keep the left, differentiate the right, plus keep the right, differentiate the left. So if you simplify them, this is what you will get. 12y square dy dx squared. Okay. So over here, you need to be more sensitive that if you take the 4 out, you can see that you have a y cubed d square y ds squared plus a 3y square dy dx squared. So you can see that this whole thing is actually same as this. Okay, so that means this one is going to become 1/4 of d square v ds squared. Okay, then this whole thing over here is the same thing as over here. You can also make it become the 4 can go over here as divide. Okay, so actually it's considered quite straightforward already. Quite straightforward already. So or what we can do is just multiply everything here by 4. Maybe that will be better. Okay, so what I need to do now is from these equations. Okay, so if this is what I'm planning to do, I don't plan to solve this anymore. I will call this equation 1. I will call this equation 2. Then my equation 3 will be using this. Copy down the differential equation that they provide us in the questions. I multiply everyone by 4, then I get 4y cubed d square y ds squared plus a 12y squared dy dx squared. This one I group them together plus the 4y cubed dy dx plus the 4y power 4 equal to the 4e power negative 2x. So this 1 and 2, with the help of 1 and 2, we will have a d square v dx squared plus the dv dx plus the 4v equals to the 4e power negative 2x shown. Done for this part A. So now we move on. From here, from part A, we want to solve the equations. Find the y in terms of x, given that when x equal to 0, y equal to 1, and dy dx equal to negative 3 over 8. So what we can do over here is that from the d square v dx square plus the dv dx plus the 4v equal to the 4e power negative 2x. I want to write down the auxiliary equations. AE, I'm having m squared plus m plus 4 equal to 0. My m will be using the quadratic equations formula. B squared minus a 4ac divided by 2a. Then I'm having negative half plus 15 over 2i. That means my contemporary solutions will be e to the power of negative half x, a cos square root of 15 over 2x plus the b sine of square root 15 over 2x. Then I want to find the particular integrals. So I have a vp. This is the exponential function. It will be, I call it ke power negative 2x. Then from here, I get my vp prime, negative 2ke power negative 2x. And then vp double prime, you will get 4ke power negative 2x. Okay, so from here, you're going to replace them inside these equations. Replace them inside this equation, you will get vp double prime plus the vp prime plus the 4vp will equal to the 4e power negative 2x. So you will get 4ke power negative 2x minus the 2ke power negative 2x plus the 4e power negative 2x equal to the 4e power negative 2x. Okay, so you can see that oh, sorry, I missed out k. There's a k here. Okay. Then if you combine them together, you will see that you will have a 6k e power negative 2x equal to 4e power negative 2x. That means your k will be equals to the 2 over 3. Okay, so you found the k, then you found the vp. So your v will be equals to the vc plus the vp. That will be equals to the e power negative half x a cos square root of 15 over 2x plus the b sine square root 15 over 2x plus the 2 over 3 e power negative 2x. Okay, this will be your general solution. And this one is in terms of y to the power of 4. Okay, changing the v become y power 4 and you get these equations. But the question giving you the value a and b, I mean the question giving you the initial value here. We want to find the a and b. So when x equal to 0, y equal to 1. So when x equal to 0, y equal to 1, you are having 1 equals to the 1, and then you have a plus the 0 plus the 2 over 3. So from here, you can find the a as negative 2. Wait, what is my a? A is a negative 2 over 3. Is it? over 3. When the y equal to 1, x equal to 0, y equal to 1, x equal to 0, y equal to 1. Yeah, okay. So if you solve it, your a is actually a 1 over 3. A is 1 over 3. Okay. Okay, so a is 1 over 3. Then I replace the a become 1 over 3 inside. Actually, I don't need to replace, wasting time only. I just need to differentiate from the y directly. Still remain as a. Just differentiate the y power 4 directly. No need to replace a as a 1 over 3. So we can just direct differentiate from here. Then you will get 4y cubed dy dx equals to half x. This one will be differentiate square root of 15 over 2a negative square root of 15 over 2a. Sine square root of 15 over 2x plus the square root 15 over 2b cos square root of 15 over 2x. Keep the left, differentiate the right, plus keep the right, differentiate the left. Keep the right hand side. Just copy it down. It's kind of long over here, so you have to be very careful when you write down the expression. Minus the 4 over 3e power negative 2x. Now, when the x is a 0, your dy dx, even the question dy dx is negative 3 over 8. This one have to be extra careful because the equation that we have is kind of messy over here, and your y, not to forget, your y is a 1. Okay, so now you have a 4, 1 power 3, negative 3 over 8 is equals to the 1 multiplied by a 0 plus the 15 over 2b minus the half of a minus the 4 over 3. Oh, quite messy. Yeah? And we simplify them one by one. Negative 3 over 2 equals to the square root of 15 over 2b. Our a just now was 1 over 3, right? Use our calculator to simplify them. We're almost there. 1 over 6 minus plus the 4 over 3. So nice. The b is a 0. Okay. So now, finally, your y power 4 is equals to the e power negative half x. A is a 1 over 3. Cos square root of what a is a cos square root 15 over 2x. Then plus 2 over 3. Okay. But they are looking for y. So the y, the 4 goes over here. Become power 1 over 4. Done. That will be the answer for the equations for the question number 8. And these are the last questions, finally. Okay, so I'll stop the video here.